Welcome back to Chapter 1 Solutions for OpenStax Chemistry. Make sure to subscribe to my channel for more solutions. The next question, what is the volume of 0.328 grams of gaseous hydrogen given a density of 0.089 grams per liter? In this question, the given information is 0.328 grams. And the question asks, what is the volume in centimeters cubed? Now, you will need some conversion factors for this problem. You need to know that for every 1 milliliter, that is equal to 10 to the negative third liters, and you need to know that 1 milliliter is equal to 1 centimeter cubed. Okay, starting out with grams as our first unit, if we want to cancel the grams, the conversion factor that includes the grams is the density. The other unit in the density is the liter, so that goes on top. Now I want to cancel the liter, and the conversion factor that I have that includes liters besides the density is my conversion between liters and milliliters. Okay, the last step, if I want to cancel out the milliliters, I now know the conversion factor between milliliters and centimeters cubed. Okay. Starting with 0.328 grams and multiplying by the first conversion factor with liters on top and grams on bottom, the 0.089 grams will go on the bottom of the fraction and 1 liter on top. Again, remember, if you want to take the density and change it into an equality, you first write 0.089 grams equals 1 liter. Okay, our second step, we need liters to be on the bottom, milliliters on top. 1 times 10 to the negative third liters and 1 milliliter on top. The next conversion factor between milliliters and centimeters cubed is a 1-to-1 ratio, with 1 centimeter cubed on top, 1 milliliter on the bottom. All of our units should cancel, except for the centimeters cubed. Now, for significant figures, the given information has 3 sig figs. And our density has 2 sig figs. So those 2 sig figs in the density are going to limit our answer to 2 significant figures. The final answer, 3.7 times 10 to the third centimeters cubed. The next question, the gas tank of a certain luxury automobile holds 22.3 gallons according to the owner's manual. If the density of gasoline is 0.8206 grams per milliliter, determine the mass in kilograms of the fuel in a full tank. An equality that they give us is between liters and gallons. So in this question, the given information is the 22.3 gallons. And the question is asking for the mass in kilograms. Okay, the first conversion factor that I need has to include gallons, and that is our equality between liters and gallons. So the units of gallons will go on the bottom of the conversion factor, liters on top. Next, I want the liters to cancel. And I do not have a conversion factor given with liters, but I do have a conversion factor given in milliliters. And I do know the conversion factor between liters and milliliters. Remember, for every 1 milliliter, that is equal to 10 to the negative third liters. Now that I've converted to milliliters, I can use the density of the gasoline, with the other unit being grams. The question is asking for kilograms, so my last conversion will be from grams to kilograms, where the equality is 1 kilogram equals 10 to the third grams. Okay, starting out with that 22.3 gallons, we will first multiply by the conversion factor between liters and gallons. 0.2642 gallons in 1 liter. The second step is to convert from liters to milliliters. Milliliters on top. 1 milliliter on top for every 1 times 10 to the negative third liters on the bottom. The next conversion is from milliliters to grams, so we're going to use that density of gasoline. 0.8206 grams on the top, 1 milliliter on the bottom. And our last step from grams to kilograms, 1 kilogram on top for every 1 times 10 to the third grams on the bottom. Again, all of my units should cancel, except for my units of kilograms. The final answer, based on the number of sig figs, the given information had 3 sig figs, the density had 4, and the gallons to liters also had 4. Everything else is exact, so our answer should be 3 sig figs based off the least. 69.3 kilograms. Thank you for tuning in. Please make sure to subscribe to my channel in order to see more videos.